standard form first and then vertex. So be careful which one you copy down.
Somebody's gonna do it wrong.
So what did I just say?
They're backwards.
They're backwards. So be careful how you copy them down.
Do we need to memorize these?
Yes.
So CW stands for clusters, right?
C.
So we do our classwork into our journal. So you don't necessarily turn it in, you just at the end you can
Sometimes you turn them in.
How will I know? I don't have describing the block transformation.
You guys did
I bet you guys wouldn't tell you nothing.
Okay.
You probably would.
So you aren't going to take any out, right?
No.
Fantastic.
Just skip down. Like right at the beginning.
Brooks took it as
What are you talking about? We got our word Even though
We got it wrong.
You write it down, everybody?
Yeah.
All right, so vertex form is where I'm using my H and my K. This ties back into our transformations, right? Where H is telling me to go what? H tells me to do what?
Up and down.
H tells me to go
left and right.
and K tells me to go.
Up and down.
All right, and A tells me I'm doing what?
Compressing or stretching?
A tells me if I'm stretching or if I'm compressing. All right, if I'm stretching, A is going to be what?
Long, taller. Wait,
Greater than one.
Greater. It's going to be greater than 1. Put your foot away. Okay? And if I am compressing, A is going to be between what?
0 and 1.
0 and 1. If A is negative, what does that mean?
It's gonna flip.
I'm going to be reflected.
No.
All right?
So I have a question. So if negative and say it's -5, it's still going to be stretching?
It's still going to stretch. It's just going to be reflected. All right? Standard form. Standard form is what we are able to factor with, right? When I'm in standard form, I can factor this. I can factor this using CAV. I can factor this using mental math. I can factor this using the quadratic formula. Okay? So when I'm in standard form, I have options of factoring. I don't need a calculator to find my x-intercept. All right? Any questions?
No. Not yet.
Yes.
He said not yet.
Oh, not yet?
Yeah.
Okay. My bad.
It's okay.
All right, what we're going to start on is standard form. So when we're in standard form, there's a certain way to find the vertex. Okay? When you're in standard form, in order to find your vertex, you have to use the following formula. Your vertex, first thing you have to do is use this formula to find x. So step 1, you're going to use x equals negative b divided by 2a. Doesn't that sound a little familiar?
No. It sounds a little sounds like the quadratic.
It sounds like the beginning of the quadratic.
Sounds a little foreign.
That little squiggly line you put right there.
That's a 1.
Do we have to put the thing at the top too with the question mark?
Huh?
Do we have to put the thing at the top too with the question mark?
No, you can. Okay? Why? The reason why there's a question mark for your y is until you figure out what x is, you can't plug in and solve for y. Once you find out what x is, your second step is to plug in and solve for. So you're going to plug in. So step 2 is to plug in.
Oh, man.
I don't have no room.
All right, step 1 is you're going to use x equals negative b divided by 2a to find your x. And then step 2 is you're going to plug in the equation to find y.
So 1 is the equation.
So 1 is the equation, and 2 would be what you would plug in. Well, 1 is the formula, and 2 is what you plug into the equation. We're going to do an example at the bottom, so hold your questions until we do the examples. Is it okay? Because I think once you see it in action, you'll feel less, that's not even a word, less concerned.
So really what you're gonna do is you're gonna plug that in for x.
And then you'll give you your y. All right, vertex form is a little easier. Whatever h and k are, that's your vertex. Whatever h and k are, that's your vertex. So as long as you know h and as long as you know k, okay? If h and k do not exist, if no h and k, therefore, where's your vertex?
The origin.
The origin. If there's no h and k, your vertex is at the origin. Cool?
Yes.
All right, moving on, peeps.
Coolest thing ever.
Now we're on to axis of symmetry. When you're in standard form, to find your axis of symmetry, you're using that same formula that you used to find your x value for your vertex. And that's because your vertex, if you know your vertex, then you know your axis of symmetry. Because what is your vertex? Your axis of symmetry is the what value? X value. As long as you know your vertex, you know your axis of symmetry. Alright, so therefore in vertex form, your axis of symmetry is whatever h is. So whatever h is,
I like vertex form better. So it's the axis of symmetry is whatever h is. So oh yeah, because that's x.
Exactly. Alright, so now we're on to y-intercept. Y-intercept, when you're in standard form, is simple. Your y-intercept is simply whatever c is. Okay. And y-intercept form, it's whatever c is. Why is it whatever c is?
Because it's what you said.
It's the constant.
Because
Well,
that's c is the y-intercept. That's the
Constant is the one.
It's the constant, but the reason why is that if x is 0, when I plug 0 in for everything, everything's going to cancel out but
c.
c.
C is for constant, right?
C is, well, it's the variable used, but it's coincidentally stands for constant.
I don't understand.
Okay?
You made it confusing.
Alright, so your y-intercept. Y-intercept means that x equals 0, right?
Yeah.
So if I was to take x equals 0 and I was to plug it into this equation, what happens here?
Nothing.
It cancels out. What would happen here?
It
Cancels out.
And all I'm left with is
C.
C. That's why your x-intercept is
Okay.
C. Alright, the reason why you need to keep that in mind is because when you're in vertex form, you actually have to plug in x equals 0 and solve.
Now let them
You actually have to plug in x equals 0 and solve
What equation?
work backwards.
The equation?
into the equation.
Why? If you know it's going to cancel out.
It doesn't cancel out here. When I plug in 0 here,
Oh, it's the Y.
mhm,
Okay.
in vertex form, you actually have to plug in 0. Alright, questions?
No.
Alright.
So the question said, you use a vertex form, you can't choose.
Well, the problem will be either given to you in standard form or given to you in vertex form.
So you can't choose.
You can manipulate them into what you need to be, but that's if you choose to do the extra work. Alright, now this is going to be a lot, so do not write anything yet, okay? So do not write.
Oh my god.
I said do not write.
It's about 5:30, right? Correct.
Your extra credit? Yes. Alright, so point of symmetric to y-intercept. We're going to write this in an easier term than what Ms. Brooks provided us with.
That's your
Huh?
That's your mom.
What do you say? That's your mom.
Alright, what we're going to do is the easy way of saying to find the point symmetrical to your y-intercept is determine
You're welcome.
how far y-intercept is from axis of symmetry. Oh, Pootie.
Right, Wookie over
It's like booty and poop put together. Bless you. I'm losing weight.
Okay, so first you need to determine how far y-intercept is from the axis of symmetry. So if my intercept is at 0, 0, 2, right? But my axis of symmetry is at 3, how far is 0 from 3?
1.
How far is 0 from 3?
3.
3! 3!
I don't know why. I'm thinking 2.
I don't know what y'all are thinking. We're going back to first grade. I said, how far is 0 from 3?
Yeah.
I did too.
I was like, come on.
Wow.
And we said 1 like she was talking into 1.
All right, let's try that question again. Ready? How far is 0 from 3?
3.
3, okay? 0 is 3 numbers away from 3. All right? And that's to the left of it, right? In order to be symmetrical, if I went 3 to the left, I'm going to have to do what on the right?
3 to the right.
3 to the right. So what's 3 plus 3?
6.
6. So my symmetrical point would be at
6.
6. Okay? Are you being funny?
No, seriously. Because the 6 divided by 2 is 3.
I was talking to Trevor.
But he said 3.
Wait, what?
Okay?
That's it.
So you determine how far y-intercept from the axis of symmetry. Then,
Oh, there's more. I didn't leave room.
did you not see me leave room?
I thought you wrote small.
I would have written big if it was going to be the whole thing.
You talking about my today? You gonna write a third line?
No.
Okay.
Okay? So then you figure out how that is, and you're going to add or subtract it to x. If I'm starting off on the left side, then to figure out the right side, I have to. If I'm starting off on the right side, to figure out the left side, I have to subtract. And we're going to do an example. Okay? Now, next part. Do not write either.
Oh, man.
The reason why you do not need to write it is because we do not use 83s and 84s. What do we use?
T7.
CX's.
Yes.
T.I. inspired.
Which one?
Something.
T inspired.
We use CXs, actually. TI inspire CXs.
I called it.
Are those the better ones?
It's what you use every day in
Why
class,
does it say
Nick.
school property on it?
I don't use it.
Because it belongs to the school, Trevor.
Brand it is?
Alright, so because we use TI inspire CXs, our steps are first, we, yes, leave room. Graph the equation. Second, you're going to press menu
It's a 7. It's not
6 1. And when you press menu 6 1, what number are you looking for, Nick?
4.
It's somewhere around here.
It's right here.
Miss, what number's my calculator?
Number 8.
Need it?
Oh, it's not here.
Yeah,
Bro.
I'll figure it out, Trevor. Menu 6 1. And remember, when it says lower bound, that means we go what direction?
Left.
Left. And when it says upper bound, we go to the right.
Is
Okay?
I'm gonna say corner?
No, we shouldn't. Because we're not doing systems.
Alright.
Alright, and then step 3 is you repeat step 2 again.
Menus.
That's the last step.
It looks like it.
Okay? Now. Yeah, it is. Now, if I don't have a calculator, what is the other methods I have?
Hand.
By hand doing what?
Graphing.
Factoring.
Oh.
Cab.
Factoring. We have cab. And we have quadratic. And if you want to use magic, go right ahead, Joey.
You know, Ms. Ware, I don't ever use the quadratic.
I thought you said ever use magic.
Alright, so you either do factoring, cab, or quadratic formula to also find your x-intercepts, which we all learned how to do. I don't know if Trevor did, but we did.
You wrote?
I wish I was from Louisiana.
No, I just don't know if you did.
Wait, which one's quadratic?
And it
Power.
X
X
equals
squared plus B. Go ahead, say.
x equals negative b plus or minus the square root b squared minus. Okay, good.
I have to see the formula there.
It's right there on that orange paper.
He had a dog. He was like,
Oh, yeah, we use that.
All right, are you ready for our examples?
Of course.
Let's see. We're going to do this one first. I'm going to identify what form we're given. What form are we given, India?
What formula are we giving?
What form?
Vertex.
No. Stop talking. We are given standard form.
Yeah, actually, this is not, but it's not. But I still wouldn't have known that either if you would have asked her.
I bet I would.
Hey, it's in standard form. I have my ax squared plus my bx plus my c. So, the first thing that you should do, just to make sure you understand what each variable is, to identify what you have. What is a in this problem?
X.
No, a is coefficient. It's a number.
1.
1. What is b?
-2.
And what is c?
3.
All right. So I've identified all of my coefficients. A is 1, B is -2, and C is -3. How do I find my vertex in standard form? Looking up top. You tell me.
What'd you say?
How do I find my vertex?
Negative
Plug
B,
in
Q,
X
A.
Plug it in.
equals B over here.
So I'm going to plug in x equals -b divided by 2 times A. Do I know what my B is?
Yes.
Yes.
What is it?
2.
What kind of 2?
Two.
Negative 2.
Positive 2, right?
No, it's negative.
I mean,
Oh,
you have the two
oh.
negatives.
When I simplify, it's going to become
It's -1. What?
a negative times a negative is a
Positive.
positive. So I know my x value. What do I do to find my y value? What was the step 2 to find the vertex?
Plug into the equation.
Plug into the equation.
Then you
So I'm going to take 1 and plug it into the.
She said she has no room.
Oh.
You have a back page? It's blank.
Nobody got no back page.
So what is y?
One square minus, oh wait, minus 2.
6. -6.
2.
1 divided
3 and
2
3.
is negative 1.
Negative 4.
Is negative 4.
It's -4. So what
That was close.
is my vertex?
1, -4.
1, -4.
One negative.
There's not even enough room to write that.
That's what I'm saying.
There's a back, buddy.
I told you to use the back.
Look, you can do the top flat.
Right at the top. Just bend it down.
No, I just wrote it over there.
Alright, so I found my vertex. Now that I have my vertex, can I easily say what my axis of symmetry is?
Yes.
What is my axis of symmetry?
X equals 1.
X equals 1. Your axis of symmetry is the x value. Can I find my y-intercept now?
Yes.
What is it?
0, -3. I mean,
Negative
no.
4.
Yeah.
4.
No, Nick, you're right.
Oh yeah, because it's the B.
It's your C. Remember, your y-intercept is whatever your C is, and what did we say C was?
-3.
-3. So my y-intercept is 0,
-3.
-3.
Okay,
Yeah, whatever.
All right, we need to find the point that's symmetric to my y-intercept. So the first thing, what did we say we need to do?
determine
Yeah.
how far from the y-intercept is from the axis of symmetry.
All right, so how far is 0 from my axis of symmetry?
1.
1, and what
3.
direction is?
And then
1
right.
to the.
Wait, it's 1 away?
Right. Wait, what? It's because the x, so x equals 1, so it's 0.
So it's 1 away from 0, -3.
Okay, so let's think about this. My axis of symmetry. Guys, stop. Stop. My axis of symmetry is where?
1.
1. My axis of symmetry is 1. How far is 0 from 1?
1.
It's 1 to the
Right.
Right.
Left.
1
left.
is over here, and this is -1.
So how far is it from my axis of symmetry?
0 to 1
Oh,
is
1, 0 to 1 or 1 to 0?
Oh, you want to go to 0?
Yes.
Or you want to go to 1?
How far is 0 from 1?
-1.
It's my axis of symmetry is what's dividing me, right? So this is my axis of symmetry at 1. Where does 0 lie in
To
comparison?
the left.
To the left, right? 0's over
Oh.
here.
Alright.
So in order for me to say symmetrical, I have to stay the same distance to the
Left.
right.
Right.
So
Man.
what would be the number over here?
1, 2.
2. Remember?
Why is it 2 again?
Because in order to be the same distance apart, if I'm subtracting 1 to go this direction, I'm going to have to add 1 to go this direction. So what would be my,
1 to the right.
2. -3.
so my mirrored point would be 2, -3. My y values are going to stay the same because I want to know what's the mirrored point.
So really, you don't have to, like, you can just
I
think
get it,
about
but I-
You can think about it, but you need to understand what's
I
happening.
don't understand.
Yes, Brittany.
Do it again.
Okay.
Okay.
Why is the one to the left?
Okay? All right. Guys, can y'all do me a favor in the side conversation? All right, Brittany, the reason why it's 1 to the left is because we know that our y-intercept is always at 0, right? No matter what, your y-intercept, the x value is always going to be at 0. That's why it's the y-intercept. However, your axis of symmetry is what changes. So we want to know how far is our y-intercept from our axis of symmetry. The distance is 1. So if the problem asks you what is symmetrical point, in order to be symmetrical, I have to be the same distance from the axis of symmetry. So if I'm 1 to the left, in order to find the other one, I have to be 1 to the right. So what number is 1 to the right of 1? 2. So therefore, my symmetrical point is at 2, -3. Symmetrical means that my y value is going to stay the same. The only thing that's changing is my x.
So how do we get the -3?
We got -3 because it said, what is our c? And because we're in standard form, it says, what is our c? And what do we determine c to be?
Oh, -3.
-3.
Because whenever you do everything else and you put 0 on the other ones, that causes cancel out.
All right, x-intercepts. We have multiple options. We can graph, we can factor, we can cab, or quadratic formula. What's the easiest with this problem?
Graph on the back.
Actually factoring. It's mental factoring, right?
Oh, yeah.
My a is 1, so it's mental factoring. So if I was to mental factor this, what times what gives me -3, but adds to give me -2?
-1 and 3.
Reverse it.
Okay.
Oh, yeah, 3, -1. Oh, no, -3.
-3 and a positive 1. Because -3 plus 1 is? And -3 times 1 is? Aren't those the two numbers I needed?
Is that the intercept?
You said 1 times -3.
1 times -3 is?
Okay.
-3.
-3.
1 plus -3 is? -2. All right, what this allows me to do is to say, if I was to solve this for 0, what would x have to be in order for this to be 0? 3. So one of my intercepts is at?
3, 0.
3, 0. What would x have to be in order for this to equal 0? And those are my two x-intercepts. Now I'm able to graph this, right? I have a vertex, I have y-intercept, I have reciprocal points, I have my x-intercepts. Could I graph this
So
problem?
we're going to have to memorize all of this.
The steps?
It's a lot of stuff.
No, it's really not.
They all like go in.
Exactly, they tie back to one another. And once you see the tying back to one another, you're good. All right, so now we're on this part. So at this problem, we're going to identify again what our key coefficients are. What is A? If there's no 1.
1.
What is H?
1.
And what is K? It's not a negative 1.
-4.
Okay, that's how.
Yeah.
Remember, we transformation, that's what the formula is.
So if it's positive, it would be negative.
No,
Mhm.
no.
I'm not going
Remember transformation.
You confused me.
Okay, so we know our coefficients. Now it's just left for us to use our coefficients. Which coefficients help us find our vertex?
to HK.
H and K. So as long as I know H and K, I know my vertex. What's H?
1.
What's K?
-4.
Which coefficient helps me find my axis of symmetry?
1.
So x equals what?
1.
All right, how do I find my y-intercept?
You plug x equals 0 into the equation.
Beautiful. Hey. That means she can read. X equals 0. So I'm going to plug it into the equation. So now I have y equals 0 minus 1 squared minus 4. So what does y have to be?
Negative 3.
I end up with 1 minus 4, which equals,
-3.
so what's my coordinate?
0.
I like your 9.
I made a 9.
4. the end of the first one.
It's a 4. It's not closed.
So,
I like
It's not. I can
I
get
thought it
that.
was a 4, it's okay.
I don't know what you're talking
I
about.
knew it was a 4, so.
Anywho's.
So Wookie.
Alright, so we're here, and we need to find the point that's symmetrical to 0, -3. So again, you identify my axis of symmetry is at 1. My y-intercept is at 0. How far are they from each other?
1.
So how far right do I need to go?
1. So it's 2 -3.
So my point would be
2 -3.
So it's the same
Starting
equation.
having
It's
kids
the
on
same
that.
thing. So it'd be 3, 0, and then 1.
Have y'all noticed?
Yeah, I know it's like the first one.
No, we did this on purpose. I gave you the same on purpose so that you can realize that they can come in different formats. The same equation can be written in 2 ways. It could be written in standard form or it can be written in vertex form.
Y'all come up with these equations on your own.
No. Yeah.
Oh, because that stuff is hard.
No, it's not hard to come up with.
But to make them come out the same.
It's not hard.
You just take one from the other, like 1 and 2.
It's not that bad. I promise. Alright, so when we do that, now we're going to actually practice doing it with the calculator. When you're in vertex form, it is a lot easier to use the calculator than to factor. Now, if you choose to factor, what you need to do is convert this into standard form. That means you would need to do FOIL and combine like terms. Or just pick up the calculator. But if you don't have a calculator at home, what's your option? To FOIL and combine like terms.
Oh, yeah.
Alright, so let's do the calculator. With the calculator, all we have to do is press what?
Menu 6 1.
Menu 6 uno.
It's not though. Just so you-
Okay, so you put it in the calculator. Notice I have it in the calculator.
I put it in the question.
I'm going to do it again. So I went home, pulled a graph page, and I typed in the equation. So I typed in parentheses x minus 1 squared minus 4. I hit enter, and there's my function. To find my x-intercepts, I did menu 6 1. Lower bound means I start on the left, hit enter. Upper bound means I go to the right, and I hit enter. So one of my intercepts is
1 -1 0.
-1 0. And then it tells me step 3 says to repeat step 2. So menu 6 1. Lower bound means I go to the left. Upper bound means I go to the right. And it tells me my zeros are at
3 0.
3 0.
Alright.
Hey, that's not the rule.
Alright. So
It don't work. It is 906.
I changed the battery, but it still isn't working.
It's gone.
Did you turn it
Put
back
them in
on?
backwards.
Not. It doesn't turn off. Alright, so what we're going to do is before you start your classwork, we're going to do a classwork problem.
That's our bill.
It's not our bell. What you're going to do is the group that, guys, listen. On the back of your notes, hopefully you have a little room. I want you to solve these problems. The group that solves all 5 parts and graph a sketch of it on a whiteboard receives 10 extra points in their homework for tonight.
Hold on, wait. On the whiteboard?
Let me go get a whiteboard.
So you need to, on the back of your page, you need to have this.
Of this, the notes page?
On the back of your notes, you need to fill in this box. And then on the whiteboard, you need to have plotted the function.
Yes, I do.
Alright, so, go.
Fastest or whoever gets it right.
The first done.
Oh, and listen, while we tell you.
You need to get it first done and it needs to be right. All of it needs to be right.
So what we... Where my notes go? Oh, it's right here.
Are we doing number 1?
Negative B.
Huh? You're doing this one. Oh, it's okay. I didn't know you were going to color it.
It's me.
I'm sorry. Do you have room on the other page? That's next to it?
2 is 2. Because negative 4 over negative 2.
Negative 4 with 2.
Oh, okay.
0, negative 6.
No, you gotta plug it into the equation. You gotta plug negative 2 into the
Yeah,
equation.
x equals negative 2.
Yeah, negative 2 squared. 4 times negative 2. 4 plus 4 minus 8.
Wait, we have to write on the back of our notes, or we can write right here?
It's not the same problem. That's your homework for tonight.
Oh!
The problem's right here.
I was doing this problem. Oh my gosh.
I told you it was on the board.
What the heck?
Why would I tell you to write it on the homework?
I don't know.
Negative, yeah,
Negative,
negative 6
oh,
over 2 times negative 2.
little head.
We're at the end of your heavy one.
3x equals 3.
Work as your team. Talk about it with each other, guys.
So it's x equals 3, right? X equals 3.
Yeah. 25.
That's what that,
3 is 25.
And then the vertex has 25.
Yeah.
That's it.
So negative 3 times 9
Plus 18.
18.
27 minus 2 is 25. That's 325.
that's this right here.
3 is 25?
It's already in the standard.
Yeah, because 8 is
Oh,
3 is 25.
So x is a symmetry. X equals. Negative b over 2a.
And then 3, x equals 3.
Y-intercept.
Plug it in.
Everybody in the group has to have the same answer.
Let's do that.
0, negative 2. It's a c. 0, negative 2. Point symmetry.
Okay.
So here's negative 2, so that's 2.
No. Why? No.
Oh, but there, it's
The
3.
axis symmetry.
So 2, 5, that's 5. And then over here it's 10.
Oh wait, the axis symmetry is 3.
So right here, so here's 3, and this is 3 to 5, right?
So then here's 1, 2,
And then
okay, so then 1, 2 is 4. I mean,
No, so look, it's 3 away from 0. So you're gonna go 3 this way, minus 4, 5, 6. 6. So 6. Yes, that's it, 6.
oh wait. Point symmetry to y-intercept. Y-intercept is what? What is y-intercept?
0.
2. So our axis symmetry is 3.
right here, there's 2.
That's 5. That's 5.
Yeah, that's 5.
That's 5 right there. So this would be
That's 5.
that
I
would
forgot.
be 8.
You got how to be.
But is this
So negative 5, 8, right?
You gotta keep the negative in mind.
And then the x-intercept. Graphic.
I know.
You gotta keep that negative in mind.
I'm trying to factor it. You have to factor it.
Oh wait, if you just
I thought you skipped some math.
yeah.
We're on the point of symmetric
But
4 and 1.
Keep the negative in mind.
yeah, negative.
You gotta factor the negative out before you do that.
Oh.
How far the exit is? Yes. From the axis.
Oh, you got it.
So you want to make it so 3?
If the 1 is, let's see.
0.
You see 6
That's what I got for the first one.
Did you graph it? Yeah, graph it. Plus 6. X.
Negative 8
Yeah.
squared.
So the vertex is for the
0.354. Listen to me, 0.354.
Oh, we all can write?
Yeah.
Oh.
Then,
If you were to factor this, the fastest way would be to use quadratic formula, FYI.
Oh wait, I thought the x has to be 0. No, you're right.
5.65. You can check our answers.
You done?
Wait, we didn't graph.
You gotta graph
Oh, we
it.
gotta graph it?
Mm-hmm.
Board?
No, right here, yeah. So, right here. And
That one, I thought it was negative, wasn't it?
Right here. No, but that's your plus. So you can make it right.
No, you gotta go up here and you gotta make sure that the vertex is right.
The vertex, it was 325.
Do you have the paper part of the paper wrote down? Which part, babe? Like when we were solving. Hold on, let me bring my paper.
What the?
Just draw it, Evan.
There it goes right there.
Okay, we're ready.
Now we're done.
Ready?
Yes. I'm not gonna erase it with that.
You know this part where you wrote the one and then you went over.
Yeah.
How do you know, like?
Because you know your y intercept is always at 0, right? So how far is what's the
No. How do I know? How come I wrote a straight line up and down?
Because that was our axis of symmetry, and we were trying to figure out how far is 0 from our axis of symmetry. You either do that or do the 56 one. If you're trying to do it by hand, it's quadratic formula.
That I'm going to figure out to go by.
All right, let's see. Why does this say 25?
Miss.
No. They're wrong. Ooh.
Miss, we right. We got it right.
Still on the board.
Right here.
Miss,
They were next.
Miss Jones, Miss Jones.
Never mind, go to him first. Where are all your answers? Y'all didn't even follow instructions.
Okay, we're done.
Stand to please.
Yes, that's the only exactly.
You're
We're
done.
done.
Write down your answers.
Excuse us.
You gotta wait.
Why?
Over here. Answer.
There you go.
Yes, but it's not 25. It's almost.
Okay, we're ready now.
They were next.
Oh my God!
Back to you guys.
Okay.
Almost. That was an almost. Which one was almost?
No, this you're closing it.
Okay. Okay.
Whoa!
Okay. All right. Now your homework.
Yeah. Is this the homework? Okay.
Miss, which one was almost?
You're almost.
Yeah, you said almost. Which one was almost?
Too bad, man.
Oh! Symmetry. Yeah, I don't know how to do that crap.
All right. The answers should be the vertex is at 3,7. The axis of symmetry equals 3. Your y-intercept is at 0, -2. The point symmetrical to it is 6, -2. And your intercepts should have been at
Everything happens for a reason, right?
all right, and then when you graph it, you now have everything to graph it with. I know where my vertex is at 3,7, so I can go 3, 7. I know where my 0, -2. My axis is at 0.354, 5.65, and the reciprocal point is 6, -2. I can now connect the dots and graph my function. All right, that's what you're doing on your homework tonight. You have 4 problems.
Is it gonna be as hard as that one? Or are they gonna be whole numbers? No, because like to graph it, it's like 0.3.
Oh, man.
You can always use a quadratic.
Can you tell me again how you do the axis of symmetry, or the point of symmetry or whatever?
All right, so
'Cause I
axis
didn't
of
really
symmetry.
understand that.
Cool.
Yeah,
I would love
guess
to.
I'll just look at your computer.
All right, so axis of symmetry. First, you identify where your axis of symmetry is. So you understand why it's here, right?
Yeah, because. Yeah.
So pretend that's a straight line.
Yeah.
That's the straightest.
Close enough, yeah.
Okay, and then once you find your y-intercept, it's always going to be at 0, right? So you want to know how far away is this
From 0.
from 0. And in this case, it's
Just 3.
3. In order to be symmetrical, I have to also go
3 to that side.
3 to this side, and that takes me to, and 3 plus 3 is,
6. So,
and that's your symmetrical point.
okay, I
You see it?
Yeah, I see it.
Perfect.
Do I need to leave my room and lock for you to do your?
Well,